Okay, so now that we've talked about the 5 types of reactions, let's go back and review them and make sure that we can identify each and recognize the basic form of them. So if you have a list of reactions that you're trying to predict the products for and balance, I think it's a good idea to go ahead and label each type of reaction before you try and predict the product. Oftentimes you'll be asked to do this, but even if you aren't, go ahead and put an SR beside it for single replacement or a C beside it for combustion, just so you keep that straight in your mind. So the first type that we looked at were combustion reactions, so I'll just put a C here. So remember, a combustion reaction we recognize because something combines with oxygen gas. So we remember if it's a hydrocarbon, plus O2 gas, we produce CO2 gas plus H2O gas. Okay. So the other type of combustion reaction that we had was the combustion of a metal. So that somewhat falls into the synthesis category, so we'll kind of put it between. So we could have Mg plus O2 gas. Okay, then we just stick them together there. So we could call this a combustion, but we could also call it a synthesis. Okay. So that leads us to the next category, synthesis reactions. So synthesis reactions, remember we only had one product. Okay. Typically we combine 2 things to make one product. So remember, there are several different categories that we had to remember. So hopefully you've learned your patterns by now. You made some flashcards and know if you see a metal chloride plus oxygen, plus water, for example, you will know what to put there. Or if you see just a direct union example, something like magnesium plus chlorine, you'll know what to do there and simply stick them together. And so really the big thing here is just to remember the different categories and different patterns. And I misspoke earlier. There's not a category for metal chlorides plus water. You need to know metal chlorides plus oxygen, what that reaction produces. So then we have decomposition reactions. So hopefully decomposition reactions aren't difficult because they are the exact opposite of all the synthesis reactions that we learned. So we recognize decomposition reactions because we have one reactant. And so one reactant decomposes. If we only have one reactant, the only chemistry that it can do is break apart. Okay, so it has to decompose. And a lot of times we'll see a catalyst like heat or electricity applied there. So you should be aware that synthesis and decomposition are the exact opposite of each other. So then we get to our the two more difficult types of reactions. We have single replacement. We'll look at first. So we see something like, we'll just say AB plus C. Okay. So a compound plus a single atom, so a single metal or a diatomic halogen here. Don't forget, for single replacement reactions, you have to use the activity series. Okay. If you just completely ignore it, yes, you'll get a lot of them right, because if the reaction actually happens and you get lucky, you won't necessarily need to use it. But there's no way to know that it's going to happen without consulting the activity series. So you have to do that to make sure the reaction happens. So for single replacement, if the reaction doesn't happen, no reaction can be an answer on occasion. But if you're doing an assignment and you get 10 no reactions in a row, maybe go back and double check and make sure you're using the activity series correctly. Then for double replacement, we have something like AB plus CB yields AD plus CB, okay, where we have an aqueous solution combines with an aqueous solution to produce an aqueous solution, and then either a solid or a liquid product. Okay, if we don't have a solid or liquid product, then we have no reaction as well. Okay, so we can also have no reaction as a perfectly valid answer for our double replacement reactions. For our double replacement reactions, we can't forget to use the solubility table. Okay? If we don't use the solubility table, then we won't get a lot of these right. Okay? We won't know the phase of the product. Okay? So for every single reactant and product in a double replacement reaction, you have to have a phase symbol. Okay? So hopefully that's a quick little review to help you recognize the 5 types of reactions. Some of the supplemental information that you'll need to solve these: double replacement, you'll always have the solubility table. Single replacement, you'll have the activity series. Then for synthesis and decomposition, for the specific category, okay, there's only one small class that you'll need it, but you'll have the gas ion chart for your reference as well with those.